Hi.
Hi, Andrea. Hi, Thijs.
Hi everybody.
Hi, Susanna. Sorry, I had to look up your name again.
Hello.
So now we will have a roundtable discussion instead of a breakout room.
Looks like it. It's very weird that we have no idea on how many participants are there listening to us also. Do you have any information on that? Maybe attendees?
Attendees.
Yeah, I can see a number 9 right at the top. So I think we have 5 more attendees. Now it's 10.
No, I think it's more. So I just pressed on the list. So here I can see, for example, Carlo, with whom I've chatted earlier.
Yes, and I have to say that I would be happy to run a Q&A session, but I don't have the Q&A button to. I only have the discussion forum, so I'm waiting for instructions to do it.
So I guess people can post their questions over the discussions.
So I encourage the audience to use the discussion forum to post questions, and I will be happy to ask the speakers and trigger some discussion. Now,
I just tested the discussion forum. It seems to work.
Maybe I could ask you, Susanna. So it's not the first thing that I saw out of Shagit, but it's it's now upcoming, right? So can you tell us a bit about how many users you now have and how much you have in-house or user experiments? So I have only been there, I think, 3 years ago or so for a conference, and there were still many things empty. So maybe you can give us an impression on how it is now there.
Yeah, thank you very much for this question. So we are already fully operational. So we have all the primary sources running, and the AJG beamlines. So there are some which are also operational with various end stations. So for example, we have the NanoESCA end station providing a combined possibility to make photo emission electron microscopic images, both in investigations with photoelectrons in real and in the K space, and it is a very popular end station. So we have users for this, I would say, continuously. And otherwise, so since the attosecond beamlines became operational this year, we expect the first users for these beamlines in this user call. And in the group where I'm a member, we have these nanofabrication tools. So we can provide these nanostructures for later investigations with lasers. And we are also working on this setup, what I have shown. So to have this information about the optical properties and the electronic states of these nanosystems. So this is another project what we are working on right now.
Cool, thank you. And I think there's a question for you.
Yes, there is a question for Susanna from the discussion forum by Eric. I'm not really familiar with the solid state experiment, but did I see correctly that you described the electron temperature as increasing over time, not directly when probed? The electron temperature looked a lot higher than the phonon lattice temperature. Will they eventually reach an equilibrium?
Okay, so what we did is we calculated with this 2-temperature model the electron temperature and the lattice temperature. And what we saw is that the electron temperature rises within 100 femtosecond, and then it starts to decrease, and in a 10 picosecond range, it will reach the same level as the lattice temperature. And after that, I think we can call it a thermalized system with an increased lattice temperature. But this increase and decrease in the electron temperature, this is what we could probe with our pump probe setup. So the laser pulse duration, what we used is 35 femtosecond. So I think I can say that we can probe this elevated electron temperature at given time instant, and we could nicely reproduce the theoretically expected elevation and decrease of this electron temperature. And in our final time instance, after hundreds picosecond, what we saw is a moderate temperature, which in this case is a common temperature for both the electron and the lattice subsystem.
Thank you,
Can I
Susanna.
ask a question to Thais?
Please, go ahead.
Okay. The question is, so apparently there is now some opening for single molecule imaging. And you said, you made even a strong point out of the fact that one should do simulations before the experiment. So you will probably do then, or one should probably then do simulations close to some carbon resonances, or how do you know where to, or how do you scan all the parameter space, or how do you find the sweet spot for single molecule imaging? And is it done, and who will do it?
So single molecule imaging, it depends on the molecules. So there are two things. First of all, there are the heavy atoms, and I deliberately focused on heavy elements because heavy elements have transient resonances in the K edge in the hard X-ray regime. Hard X-ray regime is required for atomic resolution in principle. So this is, I think in the near term, one should focus on metal atoms. So for light atoms, yes, so we have simulation for oxygen, we have simulations for carbon, but the wavelengths are like 1 or 2 nanometers, right? So this will not give you atomic resolution per se. It might give you already a much higher resolution than we have currently, but there might be ways past it, and there might be even other nonlinear effects. So I think that I would still, at some point, maybe not now directly, but at some point, I think it's worth really pursuing this also for light elements, because with attosecond pulses, we are beating any relaxation processes in the system. So if they are nonlinear processes, and if we can shape somehow the interaction, the X-ray matter interaction, I think it will be on such short time scales. So this is why I think it's interesting. Then there are all these effects which might arise, such as Rabi oscillation, stimulated emission. Yeah. We don't hear you, Dani.
Hopefully, I tried to switch off my microphone because there's some like feedback, but yeah, it didn't help. So
yeah.
But hello, Francesca.
Hi, Francesca.
Hello.
Hi.
I'm not sure if am I producing an echo, because I also hear an echo. So
I don't hear your echo, at least.
okay.
The others.
Okay.
It can be any microphone, but
Exactly.
as long as you want to speak, you should.
I hear the same as you, that there is an echo. Yeah, I was brought on stage to want to ask directly question, and I also tell the audience that if they want to ask a question, they can be brought on stage, so they can ask you directly without having Andrea reading the question. So they just have to write on the discussion forum, and they will be brought on stage. And I want to ask a question myself, or maybe on both both of you, Daniela and Thais, that if you can, I mean, Daniela, I know you're working already on tabletop sources to do imaging with the tabletop sources. So if you think about the tabletop sources, which would be the parameters, the ideal parameters for your imaging experiments? I mean, as you have said, I mean, we tried with broadband sources, and you have to take into account that you have broadband sources. If you go for attosecond, is even worse. So what is in terms of the, I don't know, the dreaming parameters that you would have for the attosecond tabletop sources in terms of photon flux, pulse duration, spectrum, whatever?
Yeah, so I think the photon flux is the most critical parameter. And for this, I would think that very short pulses are already super good. And if they are many hundreds of attoseconds long and still rather intense, that would be, I guess, the pathway to go. We try to mitigate the problems coming from the very low intensities by going to more reproducible targets, such that you can already a small signal allows you maybe to identify those patterns which can be averaged then, and then you just have to be, I mean, you can still work with signal that is just above the noise threshold in a way. So I think that, of course, if you go to higher energies, you will drop in intensity, and there's no way around that. I would not say that 10 to the 12 watts per square centimeters is the the lowermost limit, but maybe you have seen the patterns that I showed. So single shot, single particle imaging works at that sweet spot around 20 EV. But the patterns are not, I mean, you can maybe lose half an order of magnitude. You cannot lose more than one, because then the patterns will be gone. So I think it's at the moment tough to move away from helium and this 20 something EV with single shot, single particle imaging. But as I said, I think going back to the averaging process, which attosecond science is usually anyway doing by having a refreshing but a repetitive target, could give a technical opportunity there.
But we're talking anyway of microjoule level sources in the XUV, most likely to reach the peak intensities you are describing.
Yeah. So I mean, it's of course,
second pulse is even more complicated, right?
Yes. It's of course also the problem. You do not only need to produce many photons in a source point, you need to also bring them into a small spot for imaging. And I think one can work on concepts. For example, at the Eli beamlines, that's one of the things they can do. They have the space to move tens of meters away and so on. So maybe there, but with those kind of scaling things, I think you will gain like a factor of 2 there, a factor of 2 there, and so on. So yeah, maybe you end up somewhere useful.
Thanks. And Thais, what is your dreaming source?
So I overall agree with Daniela. I also think that on the long term, it's kind of multiple exposure is more realistic and useful for HHG. Another interesting idea which one could pursue is trying to generate HHG from the sample itself. So this is if you have an extended sample or repetitive sample, because I think that it will also create just the HHG process itself, diffraction pattern. So this is what solid state HHG people are doing.
Yeah.
This will be also highly damaging, so it aligns well in methodology, but it's maybe another interesting.
The problem is to send the strong IR to do the HHG on your sample.
Yeah. So because in the end, and I had discussion with multiple people about this, but I think that if you have a finite volume and you have stimulated emission or you generate HHG from it, I don't see a fundamental difference in terms of what will come out compared to coherent diffraction, because in the end, you will have a phase shift which is related to the structure. And that's exactly what happens during the fracture.
Yes, but this is, it has been applied to small systems so far, the imaging via the harmonic generation. But
say it again.
The tomographical approach has been applied to small molecules, right? The concept is this one, not to extended systems, because that would be complicated.
But what you're saying is then electron tomography, or
from the HEG.
Oh, from the HEG, okay.
Yeah. Yeah. You can make a tomographical reconstruction, which is indeed similar to the imaging.
Yeah, exactly.
Yes. But for only diatomics or very small molecules. So there's a lot of people in the attendees, and at least, I mean, maybe we can remind them that they can simply write in the discussion forum or in the live Q&A. They can also be brought on stage, so they can chat with you live.
Well, maybe in the meantime, I can ask another question to Thais. Can you hear me, Thais?
Switching my microphone, I have
Okay.
things in the background. So,
concerning the method you described, that is again using the transient resonances, that is wonderful to prepare the target for a more efficient imaging, for which you need attosecond resolution. But then if you want to do attosecond spectroscopy on such samples, so if you on that prepared sample you want to study ultrafast dynamics, is the resonant and the transient resonance decremental, or you can really exploit it? Because it is the target is out of equilibrium, right?
Yes. So what you will see is basically a highly excited state, which maybe in the future, if we understand it well, we might get some spectroscopic information. But what I would do is I would do 2 experiments. I would basically attenuate and then do the spectroscopic experiment, which really looks at the electron structure. And if this is a complex system, you also want to know the structure, and then I would have a second part experiment where you directly image the structure and then you put the pieces together. I think this is the easier approach, but it will not be on it will be, as Daniela mentioned, you need reproducible, similar samples. It will not be on the same sample, most likely. Or you have spectroscopy which is non-damaging.
Yeah.
Dani, I have a question for you. So I applied to Fermi several times and I never got beam time. So I don't have a lot of experience, unfortunately, at the Fermi FEL. But what do you think are the most exciting imaging applications there? Can you maybe give an overview? We don't hear you, Dani.
Maybe you're muted.
Okay, I was muted, sorry. Yeah, but it's really a tough question. I want to pretend that I'm muted for longer. I heard people are imaging helium droplets there. No, that I'm just kidding. There is, I think, 6. I would like to invite Carlo Caligari to the stage and help me answering this question, please. So maybe in the meanwhile, I can say that the Fermi FEL is covering the XOV range up to something like, I think with the second stage, they go to something like 4 nanometers. So it's also the longer wavelength regime. They are doing, for example, this transient grating applications, which is not really imaging. So in terms of imaging, do you mean like single particle imaging molecules or so?
Structure determination, right? Transient gratings is...
It's not for structure determination. It's a...
but it is, I mean, it is to some degree, right? Because they also have a diffraction pattern. You mean the
yes.
Talbot, yeah.
but it's I mean the grading is used for dynamic information.
Yeah,
So I know
I
that.
think like imaging in the broader sense. To me,
Yeah.
this is also already imaging.
So
yeah, Carlo unfortunately is no longer in the attic.
Carlo left, so
Left,
he left me out in the
You
dark. Mhm.
he left. There was a tough
So I think I cannot answer your question properly, Thais. Sorry. So you want to have an overview and wherever I start now,
from your point of view, I think you already answered it. That's fine.
Okay. So I think it's Fermi is a very nice source to do experiments also along your lines. So that's a pity that up to now you didn't get beam time. So if there's someone from Fermi listening, you should definitely give Thais beam time. Many good things come out of that.
Yeah, we have to report to Carlo because
Yeah, we'll tell him.
he left.
Don't worry, I applied, of course, with Beamline Scientist, so I was not on myself, on just on my own. Yeah, no, I was just interested because
what you can of course nicely use there is for example the multicolor possibilities, which extend over a large range. There are always so you have always the coupling to the fundamental because it's a seeded laser. You need to so if you want to look at resonances, you can decide for one wavelength to be resonant and the other one then it has to be like some type of higher harmonic of that. But still they can produce something on the order of 50 microjoule per color, which is in this regime definitely sufficient to do imaging applications. And yeah, I think this can be of course exploited. They do not have, for reasons, something like a PNCCD or so, or Jungfrau detector, because they are not, I think they're not good in those wavelength regimes. So what they're using is basically our simple approach with which we typically use with the MCP and the phosphor screen. So this is probably limiting the imaging applications there to not so many because, you know, all the problems with the non-linearities and so on of the MCP detector. So
do you have your HEG source in ETH now, Daniela?
Yes, so we bought rather standard TISA laser system with 30 femtoseconds and 20 millijoules, and have a beamline over. So the whole room is something like 14 meters, and the beamline is something like 10 meters. And we currently get out something on the several tens of nanojoule level, which is not yet great, but yeah, we're in the optimization process. It was Corona.
Of course. And do you use ellipsoidal mirrors to focus and achieve a smaller focus? Or
so for the start, we have decided against a grazing incidence optic, and we use close to normal incidence mirrors, and we have a simple spherical mirror, which of course then has a very bad focus, but on the other hand is very easy to handle, and we have a toroidal mirror, and we get to a bit less than 10 micron, but it's not yet characterized, so we are in the process.
Because I was thinking to ellipsoidal mirrors, since you said to reach 10 to the 12, even with few tenths of nanojoule, you can reach with the ellipsoidals, because you can go down pretty much with...
we are convinced that the parameters that we get out of the system are already sufficient to do single particle imaging on helium droplets. For the pump probe experiments, you always should have a couple of, an order of magnitude range to work in, because as I showed in my talk, there is, for example, the effect that for certain wavelengths you can tune down the scattering response with the optical laser, and there you still want to have signal, because the goal is to reconstruct the patterns and to get out of this reconstruction or fitting with me to get the optical properties out of that. And for this you need sufficient intensities, of course. And we will work, we are trying to reach something like hundreds of nanojoule, and we think that this will be sufficient for those experiments.
We are looking forward to see your new results. Okay.
I can see questions in the discussion forum so far, anyway.
So I think we can probably.
Yeah, we can maybe.
Yes, it's already 2 minutes past 2:30. That was the limit for our discussion, but. Yes.
Thank you.
Thank you very much to all the speakers. It was a very interesting discussion. Thank you.
Thank you. Bye.
Hope to see you soon in person, Daniela. Bye-bye. Okay. Andrea, I think the stage is mostly yours.
It's my turn, and I'm going to share my screen if I manage. You should see now the presentation, I hope.
Not yet. Not yet.
Okay. So I think that we can start with the poster awards. We are approaching the conclusion of the ATOCAM workshop, but it's time to give the prize to the best poster presenters. I would like to take the occasion to thank and acknowledge all the poster presenters. We had really fruitful discussions. We enjoyed the video presentations. A lot of effort was put in the video presentation, and we think it was a remarkable plus in this poster session. And I think that we can start. I would like also to acknowledge Coherent for sponsoring these poster awards. We can start from the third place, and the third place we have. It's a pleasure for me to ask to come to stage Eva Vandele from University of Zurich, who won the third place for the poster award with the non-adiabatic dynamics of solvating cyclopropanone on cyclopropanone hydrate with efficient delta SCF. And only a few words about Eva. Eva is a PhD student in the group of Professor Luger at the University of Zurich. She graduated summa cum laude at the KU Leuven University in Belgium in 2017. And her PhD project focuses on the computational study of photosensitizer for sustainable hydrogen production. More specifically, she studied the application of the delta SCF method as implemented in the CP2K program to model the excited state dynamics of condensed phase systems. And in her free time, she's vice president of the Young Swiss Chemical Society and co-chair of the International Young Chemist Network's finance team. So I would like to have Eva on stage. And Eva, do you have something to say?
Yes, thank you very much. Thank you for the prize, and thank you for our conference. I would also like to thank everyone who visited my poster and my research group.
Good.
So congratulations also from my side.
Yes, we cannot clap, so.
We can clap.
Yeah, we are all clapping. We are all clapping.
Thank
congratulations.
you.
And we can proceed with the second place. And the second place, the poster award, goes to Gabriele Crippa from Politecnico di Milano with his poster on a new soft X beamline for transit absorption spectroscopy in solids. Gabriele received his master degree in engineering physics in 2018 from Politecnico di Milano. He's currently at the third year of the PhD in physics in the same institution, working in Udini, a joint laboratory with the CNR-IFN. His research focuses on the development of a beamline for transient absorption experiments in the soft-X and its application for the study of ultra-fast dynamics and semiconductors. And Gabriele, do you want to say something to us?
Yes, well, I would like to thank all the organization committee for this nice workshop, for these days, and everyone that joined my poster. I hope that they liked it, and well, and of course my colleagues from Politecnico di Milano and CNR IFN for their support, and they work together. So.
Thank you very much, Gabriele.
Congratulations.
Congratulations. Then, the first place of the poster awards of the ATUChem meeting is Gaia Giovannetti from DAISY with her poster on a table soft X-ray beamline for transient absorption experiments in liquid phase. Congratulations, Gaia. The aim of Gaia's PhD project is to develop a tabletop attosecond soft beamline which combines high harmonics generation with a liquid jet molecular source for aqueous phase experiments. To this end, Gaia is contributing to the design and construction of the soft X-ray source. And Gaia's work has been also focused on the generation of a few optical cycle multi-millijoule CP stable infrared pulses, which are used to drive the soft X setup. In particular, Gaia aims to perform transient absorption experiments in liquid flat jets containing biorelevant molecules, which will allow to probe the molecular electronic dynamics beyond the gas phase. So, congratulations to Gaia. And Gaia, do you want to say something?
Yes, first of all, I thank all of you for the opportunity you granted me to present my work. And I would like to thank Francesca actually for assigning me this wonderful project, and also all members of my group for their constant scientific, technical, and human support. So thank you very much.
Congratulations, Gaia.
And we have to mention that Gaia is at the first place, but she was not evaluated by us.
It's good to be mentioned, yes.
Although we have been part of the first award committee, the other members have assigned Gaia the prize. So congratulations, Gaia.
Thanks.
Good. So this was for the poster awards, and I leave the word to Francesca for the closing remarks. I'm going to stop the sharing.
Okay. Can you see the screen? I guess so. Okay, sure. So thank you everybody for participating in this workshop. I think it was a very nice workshop, although virtual, and therefore limiting our the possibility of in-person interactions. So we look forward meeting all of you in person soon in the next, maybe in the next ATOChem event the next year. So I just want to remind you that, of course, we have been planning to host you at DESY and show you our photon sources and facilities, and this has not been possible. But there are also virtual tours available, so you can always visit our facilities at these links, and also our attosecond laboratory. So I invite you to have a look, especially the students. If you're interested in coming to DESY in the future, then it's an opportunity to have virtual tours, or of course you're welcome to visit us in person as well. Concerning the workshop, I just want to give you a little bit of statistics before concluding. So we had a total registration of 235 participants with an average participation per day of about 100 participants, attendees. So very good numbers. We are happy about this, and a total poster submissions of 37. So a lot of students and postdocs participated to the poster presentations with a very high level of content and very interesting discussion. I would like to thank, before concluding, of course, the core group of the AutoChem action. They have been proposing the names of the invited speakers and helping us with the program, and part of them has also participated in the poster award committee. I want to thank the local organizers, Eric Manson, Andrea Trapattoni, and Vincent Beni, who together with me coordinated and organized this virtual meeting. And of course, all the assistants we got from my assistant, Morina Alfaro, and Roberta Porchetto, as well as Beatriz and Bright Helm for supporting us in this virtual event. I just want to mention that there are several opportunities within the AutoChem network, and I would like to encourage all of you to take advantage of these opportunities. So first of all, the short-term scientific missions. So these are the core of the AutoChem cost action, so the possibility to go and visit groups who are part of the network, and we can support, of course, your mission. There are possibility of also doing lab tour videos to describe the activity of the labs involved in the action and to promote also the STSMs. And we can cover for the costs of this lab tour video and training videos at an entry level or advanced level related to the various working group activities, or also short clips focused on well-defined target groups. We can cover expenses associated to joint publications when quoted by action participants, representing at least 3 different participating cost members. And Aurora Ponce, she's mostly responsible, as Fernando mentioned at the beginning of the workshop, of all these dissemination activities. She's also organizing several webinars, so there's also possibility for dissemination via webinars on topics obviously related to the various working groups. So there are all those opportunities, so we very much look forward having your applications for these different things, and more specifically for the short-term scientific missions. So with that, I think I concluded. I really want to thank all the speakers who contributed, all the presenters of the posters as well, because it has been a very interesting workshop. I also want to remind you, for the people who want still to come to Hamburg, visit us and have the opportunity to meet in person, that we will be hosting in person next year the MOLEC conference, which is the European Conference on the Dynamics of Molecular Systems. There is a lot connected also to attosecond science as well, so this community may be interested, and this will be in August 2022, between the 21st and the 26th. So if you want, mark the dates in your calendar. Okay, so with that, I stop sharing. I thank you very much, all of you, for the participation, and I'm looking forward to meeting you soon in person. Okay, bye-bye.